Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Gianfranco Papa is CTO and co-founder of Somnio. He's Google developer expert in Flutter and Dart. In this session, he'll talk about building real-time apps with gRPC and Flutter. Let's go!
Hi, I am Gianfranco Papa, and today I'm going to talk about powering your Flutter apps with gRPC. Okay, so first I want to talk about me and who I am. So I'm Gianfranco Papa, and I am CTO and co-founder at Somnio Software. At Somnio, we are a dev shop who specializes in Flutter, and we provide development services for our clients around the globe. I'm a Google developer expert for Flutter and Dart as well. It's my area of expertise. I'm a software engineer, and I'm, of course, a Flutter developer. I'm also a mentor in Flutter. I really like to do some speaking at conference, so I'm a speaker. And also, I organize a Flutter Montevideo Meetup where I live in Uruguay. So enough about me. Let's talk about what we are going to talk about today. That is combining Flutter and gRPC for making full stack apps in Dart. As the name of the conference was Full Stack Flutter Conference, I thought about talking about how we can create this full stack app using only Dart. And one of the strategies to approach this would be to use gRPC. So this is the whole motivation of the speak. And also, we're going to talk about what is gRPC, in case you know it. Also, we are going to talk about protocol buffers, which is tightly connected to gRPC. Then we are going to integrate this with Flutter, and so you can have like a full picture on how to create full stack apps using Flutter and gRPC. And then we're going to talk about how to deploy everything in Google Cloud Run, so you can have like the full picture of like dealing with the front end, the back end, and also the infrastructure needed to deploy your app. And lastly, we're going to give some conclusions and next steps, so you can like continue exploring this topic. Okay, so the motivation, I think that when dealing with full stack applications, there are a lot of strategies out there. Maybe the most common one will be to connect a REST API with your front end. But also you can use different protocols or strategies such as GraphQL, WebSockets, gRPC, which we are talking today. Also, there are different strategies to implement or include a backend as a service, such as Firebase, Amplify, or Supabase. And finally, we can also create everything using Dart, because in the sense of creating full stack apps using Dart, we can explore different frameworks or libraries such as Dartfrog or Serverpol. But with all of these tools, I want to center today the discussion in gRPC, because it is not so spread out in the development, and I want to provide like a better understanding. So let's focus on what is gRPC, right? Basically, this is like the documentation definition. So gRPC is a modern, open source, high performance remote procedure call. We're going to decompose the whole definition right now just to understand better. But gRPC, basically, it was initially developed by Google and then open sourced in 2015. It is not other than an implementation of a remote procedure call. RPC is such another protocol such as HTTP, but it has a different properties that we can use. gRPC in particular is built on top of HTTP2 for the transport layer. That means that we have access to real-time connectivity, and that is the main difference with HTTP. The basic idea of RPC is calling a function that normally resides on the server, but as we were calling it on the client side. So basically, when using RPC or gRPC in this case, we are going to feel that we're like calling a function such as if we were calling, for example, a function that is in a library or in a package. And that's the beauty of it. We don't have to send a request and receive a response and parse it. We can only, or define a protocol, we can only like call the method, and that will be it. Other things about gRPC is that it encodes the information using protocol buffers. We are going to explain what it is. And one of the coolest things about this protocol is that it provides bidirectional streaming. So we will have cool use cases such as stream things from the server or backward. Then lastly, I want to talk about that it automatically generates idiomatic client and server stuffs. So it relies a lot in code generation. This is really handy for us because it will create based on our definitions that we are going to provide using protocol buffers, it will generate a lot of code for us, and that the developer experience will be better in that sense. Okay, so this is only the official support for gRPC and the different programming languages. So we can see that Dart is there, our main focus for today. But there are a lot of programming languages that are supported. So this is especially when development backend applications and dealing with microservices will be really handy because it has a lot of support out there for different programming languages. And yeah, you can write your own microservice in your preferred programming language. Okay, so now we're going to talk about protocol buffers. That is what we introduce. This is really key to understand gRPC because protobuf, let's talk about like the definition as well. It provides a language neutral and platform neutral extensible mechanism for serializing structured data. Let's talk about decompose this definition a little bit more better. So you can call it protocol buffers or proto buffers or simply protobuf. There are different ways to refer to the term. And it provides like a platform neutral and language neutral definition. It is like JSON, but it is smaller and faster. You can imagine like if JSON is for like the REST protocol, protobuf will be for gRPC. So that is the analogy. And lastly, it generates native language bindings, which we are going to see how to do that. If we compare protobuf with JSON, JSON is text-based format, so it's kind of like more readable for humans because you can actually understand it by seeing the definition, and then it's a key value pair. Whereas protobuf is binary format, so it's not so understandable. But this is in this way, it's going to use a more compact and efficient encoding. And for this, we'll have the advantage of like transmitting this information more efficiently through the network, and that will mean that we will have like a more performant communication in our application. Then, thanks to this way to encode the information, we can see why protobuf is more efficient. And about the schema definition, we can say that protobuf has a strict schema definition, but it provides a more robust type safes between the front end and the back end. Lastly, it also supports a lot of programming languages. Though protobuf is a little bit behind than JSON, it is still like really supported. So there you have like a list of difference between protobuf and JSON. And then I want to talk about the proto file that is really key in understanding protocol buffers. Basically, it used to define the API interface and data types for intercommunicate between different components. Here we can create messages which are going to be like classes for us, and then the services which are going to expose the different endpoints that we want to expose to, for example, our front end the operations that are needed. It will be like the endpoints in a REST API. Then how we can create this proto file, right? So we're going to decompose a little bit more the proto file. First, we need to write to specify the syntax. In this case, currently we are in the third version, so we can define proto free. Then we are going to create a message. In this case, this is an example. So I wrote a to-do message with different properties. We only need to provide the type and the key, which is going to be and the value, which is going to be like unique. And it could be like an integer, and it could be an auto increment integer. So then we need to define the service. For the service, in this case, we are defining only two operations: get the to-do and get the to-stream. This is like one of the cool features that we can implement, streaming like something from the server. But talking about streaming, I want to talk about what are the main strategies to stream something from using gRPC. So basically, we have both server and client-side streaming. It will depend on the thing that we want to stream. If we want to stream something from the server, that will be server-side streaming. And if we want to send something to the server continuously, that will be client-side streaming. But we can also provide bidirectional streaming. So that will mean that both the client and server are sending messages to each other at any point. So how can we do that in the service that we specify? So basically, this is the notation for getting a to-do, a simple request-response flow. But if we want to start streaming information, we only have to provide the keyword stream in front of the returned type, or in front of the message that we are sending as a parameter. And if we want to do client-server stream, we only have to put the stream keyword in both places. So how we can integrate everything with Flutter and start creating full-stack apps, right? To do that, the first things to do is to create the code. From the proto file, we have to do some code generation to create some actual Dart classes. In this case, if we run this command with proto C, we can auto-generate all of these Dart classes, and that will mean that we will have access to, for example, a to-do class in Dart, or even services that can provide all of the endpoints that we define in our service in the proto file. So this is wrapped as a library, and we can start using in our Flutter app. The way we need to start connecting with gRPC is establishing a client channel, and this received like some basic properties such as the base URL, the port. This will depend on where you are deploying your server. And also we need to specify some option parameters such as the channel options. In this case, we specify some credentials as we are using SSL, and we provide a secure channel. But if you're, for example, debugging, this is not required, but in production apps, this is a good practice to follow. Then we only have to create a staff object, and this will serve as a proxy between the front end and the back end. From that point, we can start using all of the methods we define in our service class. There are more advanced concepts that I will not cover, but this is like just for you to know. You can explore interceptors, for example, for authentication services. This is really common. We need to authenticate a service, and yeah, for this we can introduce the concept of interceptors. Also, there are different ways to encode information, so coded registry will be the way to explore that. We also mentioned the SSL support for production apps, and gRPC, it actually has more support for mobile and desktop, but in this case, the web support is possible, but you need to make some tweaks there, for example, using proxy or envoy. and then the gRPC server deployment, which we are going to introduce today, and we are going to present Google Cloud Run for our solution. Okay, and now for the deployment, we're going to see, as I said before, an option, Cloud Run. So basically, Cloud Run is a service in the Google Cloud Platform that allow you to deploy highly scalable containerized applications. So basically, what are the advantages of using Cloud Run? And we can see like the full deployment. Basically, it provides a serverless architecture. That means that Cloud Run basically abstracts away the infrastructure management, and you as a developer can only focus in the application logic, and you don't have to focus in maintaining servers. Also, one of the benefits is that it uses containerization. So as long as you can containerize your application, for example, using Docker, you're going to be able to deploy it to Cloud Run with this. Also, one cool feature that it has is that it provides auto scaling and down scaling. So depending on the amount of traffic that you will have ultimately in your server, this will be managed like automatically, upscaling and downscaling, right? And in that sense, you only need to pay for what you use. The amount of time your container is running is what you ultimately will pay. So that's cool, because if no one is using your app, you are not going to be charged by minutes that your server is still running in the server. So the prerequisites are like only a few steps. You have to have your Google account. Then you need to create a Google Cloud Platform, a GCP project. And then you have to have your billing account connected to your GCP project, because it's a paid feature. Once you have everything set up, the only thing that you need to do in your machine, and if you have like gcloud installed in your machine, you only need to run this command, gcloud run deploy. You need to provide your service name, your project ID, and the region. In this case, we put allowed unauthenticated because we assume that you're already logging in using the gcloud CLI. But this is really easy, and you can have your backend up and running in the cloud, like with this little step. Then for the conclusions and the next steps, we're wrapping everything here. So for conclusions, I wanted to say that Flutter and gRPC are a perfect combination to create full stack apps in Dart with great performance, thanks to the proto communication that we explained. So this is a really nice combo that you can use for building full stack apps with these features. For example, real-time features. If you notice that you need to use that use case instead of HTTP, you can use gRPC. Also, when using protobuf, as it is language agnostic, it means that if you're using other languages, for example, if you are not using only Dart, that will be really easy for you, because it underlies the programming language, and you can provide interoperability with different microservices, for example. So next steps, if you want to continue seeing this topic, I highly recommend to see the chapter of several Flutter on gRPC that we made in the Flutter channel with Greg. Also, you can explore some gRPC documentations, the official ones and the community ones. Those are really well done documentations. And also, you can explore, for example, a blog that I made on how to build real-time apps using Flutter and gRPC, while I explain like more in code how you can set up everything. So yeah, I want to thank everyone here at the conference that I seen the presentation. Also to Victor that like magically kind of like organize the whole conference, and I know that is really difficult to do this. And yeah, I think that will be it. Enjoy the rest of the talks in the full stack Flutter conference. And yeah, thanks to everyone. If we want to reach me out in the Q&A session or in my social network, here they are. So thank you, everyone. Bye.